Good morning, everybody. So last class we were talking about the formulation of ophthalmic emulsions and ophthalmic gels. Today we'll be discussing about the formulation of ophthalmic injections, eye drops, ophthalmic drops, suspension, how it is formulated. So the other rest of the formulations we'll be studying today. So first one is ophthalmic injections. So ophthalmic injections, when you are going, the main thing is vehicle. So as it is a injection, what kind of vehicles you will be using for ophthalmic injections? Whether you will be using sterile vehicle or you will be using non-sterile vehicles for ophthalmic injections.
Sterile, ma'am.
Yes. So when you go for vehicles, there are two types of vehicles what you'll be using. One is aqueous vehicle, the other one is non-aqueous vehicle. So when you go for aqueous vehicle, water will be the most widely used solvent in the preparation of any injectables. So in that again, aqueous vehicle, the three main types of vehicles what you'll be using is water for injection, so that you know how it is prepared by reverse osmosis process. And next you will be using water for injection free from carbon dioxide. So when you go for water for injection, just plain water for injection, there are chances of the presence of carbon dioxide also. But few preparations does not require carbon dioxide, the presence of carbon dioxide in water. So you can also prepare water for injection which is free from carbon dioxide and water for injection free from dissolved air. So these are the three generally used vehicles for ophthalmic injection: water for injection, water for injection free from carbon dioxide, water for injection free from dissolved air. Apart from that, you will also use non-aqueous vehicle. So when you go for non-aqueous vehicle, generally it is used when the drug is insoluble in water. So when the drug is not soluble in water, then they will be preferring non-aqueous vehicle. Otherwise, the first preference will be for the aqueous vehicle. So what are the types of non-aqueous vehicles you will be using is, you'll be using oils like arachis oil or cottonseed oil, and even they'll be using propylene glycol as non-aqueous vehicles. So these are the two types of vehicles what we'll be using in case of ophthalmic injection: aqueous and non-aqueous. In aqueous, three types: water for injection free from carbon dioxide, water for injection free from dissolved air. And in non-aqueous, you'll be using oils like cottonseed oil or arachis oil, and you'll be using propylene glycol. Apart from that, you will be using stabilizers like antioxidants, which will prevent the oxidation of the drug. Okay, you know that. So you can use ascorbic acid or sodium metabyte sulfate thiourea as antioxidant. Apart from that, you'll be using buffering agents like acetate buffer or citrate buffer, phosphate buffer will be used in order to maintain the pH of the desired range. Next, you will be using tonicity contributors. So tonicity contributors, again, you know, in order to make the injection isotonic with a blood serum or any other fluids in the body, you'll be using the tonicity contributors. So in this case, tonicity contributor, you'll be using sodium chloride, or they'll be using borax as some of the tonicity contributors. So, but remember, as this is ophthalmic injectable, these substances should be completely free from foreign matter, and it should be compatible with other ingredients what you are using for the preparation. And lastly, you will be using antibacterial agents. So when you go for antibacterial agents, you know, it is in order to prevent the growth of microorganisms, you'll be using antibacterials. During storage, there are chances of the growth of microorganisms that will be prevented by the addition of antibacterial agents. So examples of antibacterial agents, you know, they can use cresol. The concentration of cresol, which is used as an antibacterial agent, is 0.3% in case of injections, and chlorotrazole 0.2%, phenol 0.5%, phenine mercuric nitrate, it is 0.22%. Okay, so this in this percentages you will be using the antibacterial agents. So main thing you have to write about, apart from the other general ingredients what you are using, you have to mention about the vehicles what you will be using for the preparation of injection. And next one is the preparation of eye drops. So when you go for preparation of ophthalmic drops, there are different steps what is involved. First one is dissolution of the ingredients. Second one, filtration or clarification of the solution. Third step is sterilization. So these three steps are generally involved in the preparation of eye drops. So first, when you go for dissolution of the ingredients, so when you are dissolving the ingredients, it has to be carried out in an aseptic room, or at least it has to be carried out under the laminar airflow cabinet. Okay, this you have to remember. So even for the dissolution of the ingredients, it has to be done in an aseptic room, or at least in the laminar airflow cabinet. So why you are using aseptic room or LAF? So it is, you are using LAF or aseptic room in order to reduce the number of microorganisms that will enter the solution, and thus it will decrease the contamination of the particulate matter. So this is why you will be carrying out the dissolution or process under the aseptic room or laminar airflow. So how you will do this is, you will collect first all the ingredients of the formulation, and required apparatus will be collected, and you will be taking the measured quantity of freshly prepared distilled water into a beaker or into a conical flask, and it has to be covered. Okay, so then after taking water, you will collect the required quantity of the ingredients carefully, uh, by preventing any atmospheric contamination. So when you are weighing the required quantity of ingredients, there should be avoidance of the atmospheric contamination. You should see that there will be no contamination of the ingredients. And then once you weigh it, the ingredients will be added to vehicle and it will be dissolved completely. You usually when it is dissolving easily, you will not apply it, but when it is not dissolving completely, you can use heat on a hot plate or a low Bunsen flame. You will be adding the ingredients to it so that it will be dissolved completely. So once you are dissolving it, the next one is, so you, as you are eating, it has to be cooled, and then you will be dissolving the remaining ingredients with the help of stirring. So first you will add drug, and then the remaining ingredients will be added with the help of stirring. And once it is dissolved completely, all the ingredients are dissolved completely, you will adjust the pH of the prepared solution with the help with the solution of definition. So you are adjusting the pH. Okay. So after adjusting the pH, you have to make up the final volume of the eye drop, and then again you will be checking the pH with pH meter. If necessary, again you will be adjusting the pH. Okay, so pH has to be determined. So this is how we will do the dissolution of the ingredient. So you are selecting an aseptic room or under lab, you are weighing all the ingredients. Weighing also, you have to see that there is no contamination of the product. After weighing, you will be taking the desired amount of vehicle. You will dissolve the drug. Once the drug is dissolved, the remaining ingredients will be added and it will be dissolved. After dissolving all the ingredients, we are checking the pH. If necessary, you will adjust the pH also. So once the pH is checked and when it is adjusted with the required strength, you can make up the volume, final volume. And after making up the final volume also, you will be checking the pH. And if necessary, you will adjust it again. So once this is done, the next step is filtration or clarification of the solution. So filtration or clarification of the solution is whatever solution you have prepared using dissolution process. So the solution will be filtered using microporous plastic membrane in order to get a clear solution. So in order to get clear solution, you are using a microporous membrane to filter the solution. So again, the filtration should also be carried out under an aseptic condition, and the filtrate should be particle free. So whatever filtrate you will get, it should be completely free from the particle. Okay. If necessary, refiltration can also be done. If you see any particulate matter, so refiltration can also be done. Okay. So this is the second step. So second step is filtration of the solution what you have prepared using a porous membrane. Next one, the last step is sterilization process. So sterilization can be done by three different methods. One is autoclaving method, heating method, and filtration method. Okay, so autoclaving, the solution in the final container will be heated in the autoclave to 115 degree for 30 minutes at a pressure of 15 lbs. So this is general autoclaving procedure what they'll be doing. So autoclaving generally is done for atropine eye drops, so where the final container will be kept in autoclave for 30 minutes at an 15 lbs pressure of, and the temperature will be around 115 degrees centigrade. Next, Sometimes they will also use heating method where the solution is heated to a temperature of 98 to 100 degrees centigrade for 30 minutes. And this method of sterilization is used only for the solutions like chloramphenicol or neomycin that will degrade at a higher temperature that is used in autoclaving. Then you can go for heating. Okay. So example is chlorophenol containing eye drops or neomycin or physostigmine eye drops are sterilized by heating method. And the other method what you can use is filtration. So filtration, this is generally done for thermolabile drugs where it is not able to withstand the heating or autoclaving temperature. So when you are filtering, again you have to use a sterile membrane filter under aseptic condition. And the pore size of the filters what you are using should be 0.22 plus or minus 0.02 millimeter. So that is the pore size of the filter. So remember the pore size of the filter is 0.22 millimeter. Okay. So once you are filtering, the filtrate should be immediately transferred to the sterile container. Why? Otherwise, again, it will be contaminated by the atmospheric things. So you have to immediately transfer the contents to the sterile containers once the filtration is done. So there are two types of filtration. So I told in the second step also. So once dissolution is done, you'll be doing filtration. So that is just to remove the particulate matter. Whereas here, what you are using sterile membrane filters and the pore size is 0.22 millimeter, and immediately you'll be transferring to the sterile containers. And this is for only thermolabile drugs. Whereas the clarification process, what you are doing after dissolution, it will be done for all the types of drugs. Okay. So this is about eye drops. Any doubt? Eye drops? The preparation method, all of you followed? The other things, so after writing this filtration or dissolution method, everything, you can just make a note, or you can also write about stabilizers, buffering agents, tonicity contributors, everything you'll be writing if they ask individually about eye drops. Okay. So in general, if they ask eye preparation, so at starting you can explain, and only the key points which is required for each dosage form can be explained under the topic. Okay. So next one is the preparation of ophthalmic suspension. So when you go for ophthalmic suspension, first thing is you have to micronize, or you have to reduce the size of the powder. So that is very important, so that it will not cause any irritation to the ocular tissue. So milling is done prior to the incorporation of the dispersed phase into the vehicle. Usually milling will be done by using fluid energy mill or jet mill, and again milling has to be done under the aseptic condition. So this is the first and foremost thing what you will be doing in the suspension. So all the ingredients what you are using should be in the micrometer size, because it should not irritate the ocular tissue. So how you will divide the size, or how you will reduce the size? By using milling technique. Either fluid energy mill or jet mill will be used under the aseptic condition in order to reduce the size of the particle. The fine drug particles will be wetted with the solution of wetting agent, and then it will be allowed to stand for several hours to release the trapped air. So this point is very important. So you are milling the particles. So once the particles are milled, you will get the fine powder. That fine powder will be wetted with the wetting agent, and then after adding the wetting agent, it will be allowed to stand for few hours in order to release any trapped air. So if there are any trapped air, it will be released, so that wetting of the particles will be better. So simultaneously, what you will be doing, the suspending agent will be dispersed in the vehicle, and it will be allowed to stand until complete hydration takes place. So after adding wetting agent, simultaneously, you will be adding suspending agent also will be added in the vehicle, so that there will be complete hydration of the suspension. So then the drug solution will be slowly added to the dispersion of the suspending agent. So other additives, after adding the drug solution, we will be adding other additives like buffers, flocculating agents will be added very carefully. Preservatives will also be added at the end of the formulation. So finally, once you are adding all the ingredients, the preparation will be processed with homogenizer or ultrasonic devices or collide mills in order to get a uniform product. So after adding all the things, it can be processed using homogenizers, ultrasonic devices or collide mills in order to get the uniform product. So then the preparation will be packed in the final containers, and then it will be sterilized using moist heat sterilization. So usually they'll be using moist heat sterilization process for sterilizing your suspension. Okay? So suspension, what are the different steps? First thing is homogenizing or milling of the powder ingredients. After the powder ingredients are sorry, after the ingredients are powdered, you will be taking the drug and it will be wetted with wetting agent, and in simultaneously in one more container you will be preparing the suspending agent and it will be allowed to stand. So once the suspending agent is prepared, the drug solution what you have prepared using the wetting agent will be slowly added to the suspending agent, and then finally you will be adding buffers, preservatives or flocculating agents. Once all the ingredients are added, you will process the formulation using homogenizer or ultrasonic devices in order to get a uniform product, and then it will be sterilized using moist sterilization. Okay, so this is about your eye suspension. Next one will be eye ointments or ophthalmic ointments. So ophthalmic ointments are prepared by different methods like navigation method or fusion method. So I think this you have studied. So what is fusion method and what is navigating method? So what do you mean by fusion method? Anybody? Do you remember fusion method and navigating method which are studied in your physics for the preparation of ointments? Nobody know? Navigating method?
Ma'am, in fusion method, the ingredients are melted and combined together.
Yes, the base will be melted and to that they will be adding the drug. Okay, so these two methods, fusion method and navigating method, is generally used for preparation of the ophthalmic ointment. In fusion method, what they will do, first thing is the drug and additives will be milled to get the particles of fine size under the aseptic condition. And next step is the base what they are using for the preparation of the ophthalmic ointment will be melted. So when they are melting again, it has to be melting should be carried out under the aseptic condition. Okay, the base has to be sterilized and it has to be melted under aseptic condition. And next, what they will do, whatever the drug and additives that you are milled into the fine particle size will be slowly added to the melted base, and the base will be presented in a rotation mixer. So as soon as we are adding these drug and additives, mixing will be carried out until the preparation attains uniformity. Okay. So this they will be doing. So drug and additive, they will reduce the size. The base will be sterilized and melted at aseptic condition. Once the base is melted, they will add all the ingredients to the base and it will be mixed in order to get the uniformity of the product. And then what they will do, once the uniformity is achieved, the finished product will be processed through a roller mill to get a uniform dispersion, and if there are any aggregates, it will be broken. Okay, so finished product will be processed in roller mill. Why they are passing through roller mill? In case if there are any agglomerates or if you see any non-uniformity, then you will get uniform dispersion and the agglomerates will be broken. Okay. So next, last one, what they will do, they will pack the ointment immediately under aseptic condition into sterile container. So they will directly transfer to the sterile containers under aseptic condition. Okay. So usually terminal sterilization will be avoided when you go for ophthalmic ointment. So what they will do, whatever processes they are carrying out, it will be carried out in a sterile area or aseptic condition in order to prevent the terminal sterilization. So each and every step will be under the aseptic process. So this is how they'll be using the fusion method for the preparation of ophthalmic ointment. Next one is levigating method. So in case of levigating method, this method is suitable for the drug substance where the drug is not soluble in the base. So the drug will be insoluble in the base what you are preparing. So again, the drug and additives will be milled in order to get a fine size under aseptic condition. And then what they will do is So they will not add the entire drug to the base. So only a small quantity of the drug, the drug is mixed thoroughly with only a small quantity of the sterile base or with any miscible liquid like propylene glycol or mineral oil. Then what they will do, the drug and the sterile base what you are mixed, that will be mixed homogeneously with the additives what you require for the formulation, and then the mixture will be diluted geometrically with the base. For example, I've mixed 1 gram of drug and the base. Next you will add 1 gram of base again, so you will mix it. So now I have 2 gram of base and the drug mixture. So that again you will add 2 gram of the base. So the base will be added in a geometrical manner, and then it will be finally mixed thoroughly. And then the finished product, it will be passed to the roller mill to get the uniform dispersion, which is smooth. And then it will be packed aseptically under sterile containers. So this is how they'll be using levigating method. So levigating method is used when the drug is insoluble in the base. So what you are doing here, first you are just taking the drug and you are mixing with just a part of base, and then once it is mixed uniformly, you will be diluting it geometrically with the base. At once you are not adding all the base to the mixture. Okay. So once you are prepared ophthalmic ointment using fusion method or levigating method, the next comes is sterilization of the ophthalmic ointment. So when you go for dry heat sterilization, it may decrease the stability of the drug and it may result in the separation of the ointment base from other ingredients. Okay. So and even ethylene oxide, the gaseous sterilization, what you'll do, ethylene oxide or steam cannot penetrate the ointment base, hence even they are not suitable for sterilization purpose. Also, sterilization of the preparation after manufacturing is not possible, hence strictly you have to follow aseptic techniques for the preparation of the sterile product of an ophthalmic ointment. Remember this is very important. So heat when you are using, so it may decrease the stability of the drug and the base. And even when you're going for gaseous sterilization, the gas, ethylene oxide or the steam may not penetrate the ointment base. So permanent sterilization is generally avoided in case of ophthalmic ointment. And in order to prevent the particulate matter, you have to carry out the preparation only under the aseptic techniques. Okay. So these are the things what you have to write when they ask about the preparation of the ophthalmic dosage forms. Okay. So I'll tell what are the preparation we had studied totally. So we had studied about ophthalmic solutions. After ophthalmic solution, we had studied about ophthalmic suspensions. After suspension, it was ointments. So next is ophthalmic emulsion, ophthalmic injection, ophthalmic gel, ophthalmic eye drop, suspension preparation, and ointments. So these are the preparations what we have studied. The next is very important in case of ophthalmic is the container. Okay. So when you go for containers, what are the general requirements that you will expect for an ophthalmic container? General requirements or ideal requirements for ophthalmic containers.
Sterility should be maintained and contamination should be avoided.
Yes. So first thing is it should withstand the sterilization procedure. So you are using different types of sterilization process. So terminal sterilization when you are doing, the container should have a capability to withstand the sterilization procedure, whether it may be a gaseous sterilization or dry heat, moist heat. The temperature or the type of sterilization procedure what you are following, that has to be withstood by the containers what you are using, and it should not alter the stability or the therapeutic activity of the preparation, and it should not absorb the medicament or it should not release any substance into the preparation, and it should be easy to handle. So these are some of the ideal characteristics what they will think before you selecting a container. Easy to handle, it should not release the any substances to the product, or it should not absorb the medicament, it should withstand the sterilization procedure, and it should not alter the stability of the product. Okay, next one. So container, these are the ideal characteristics. So how you will, what volume of packing. So how you will select the volume of packing. So the chance of contamination of the preparation with vegetative bacteria and spores increases with the number of times the container is open. So when you have multiple dose containers, each time whenever you are using opening the container, there are chances of the contamination of the preparation with vegetative bacteria or spores. So which in turn depends upon the quantity of the preparation which is present in the container. So usually what they will do when you go for ophthalmic, the 10 to 25 ml of the liquid preparation or less than 5 gram of the semi-solid preparation will be packed in each container in order to prevent this entry of microorganism whenever you are using the formulation. Okay, so this is why they will usually ophthalmic, they are not packed in large containers, they'll be packed in very small containers in order to prevent the growth or in order to prevent the contamination of the product with vegetative bacteria and spores when each time you are opening the container. Okay, which type of packing material you can use for the containers is usually they'll be going for plastic materials. So again in plastic material there is LDPE and IDPE, high density polyethylene. Okay, so plastic containers, you know, they are used in packing of almost all the ophthalmic products. Generally, they'll be going for low density polyethylene. The high density polyethylene is not widely preferred. They'll be going for low density polyethylene type of plastic, either with or without specifying agent or other colorants to offer protection from light. It is used to making in bottles. So you are using plastics. In that plastics again you are going for low density polyethylene. So you can add opacifying agent or coloring agent, or you may not add any opacifying agent and the coloring agent. So, but apart from LDPE, even high density polyethylene also is used, but they are rarely used. Generally used as low density polyethylene. So this low density polyethylene is also called as branched polyethylene. Why they are using this is, this low density polyethylene has the advantage that it is compatible with most of the solvents and the drug substances. So that is why they'll be preferring this LDPE. So it is compatible with most of the drugs and solvents. Okay, so next one is it has a lower melting point, so it cannot be sterilized using steam. That is the disadvantage what they have. Low density polyethylene has lower melting point, so you cannot use sterilization by steam method. Okay, so but one more advantage of this LDP is it is flexible. So as it is flexible, you can use this LDP to prepare any squeeze bottle. When you want to prepare a squeeze bottle for ophthalmics, you can prepare this LDP. So what are the LDPs? When you go for LDP, it is called as branched polyethylene, and it is compatible with most drugs and solvents. It is flexible, so it can be used for the preparation of squeezed bottle. But when you go for disadvantage or one demerit is it has lower melting point, so sterilization by steam is not possible when you are going for LDP. So you know what are the advantages of plastic. So plastics advantages are less possibility of breakage or leakage, or leakage is also less, compared chances of leakage is less, and the cost of the material will be low, and it can be easily handled compared to a glass container, which can be easily handled. So these are the advantages. But what may be the disadvantages of plastic containers? Any disadvantages that you can remember plastic containers? Nobody? Any disadvantage of plastic container? Okay, so the demerit of the plastic container is most of the lipophilic or certain volatile substances may permeate through the walls of the container. So that is one of the disadvantage of plastic container. The lipophilic or volatile substances will permeate through the walls of the container. Okay. Next one is when you are using dye, glue, or ink, which is used for labeling of the product, may also penetrate the container and it may contaminate the product. So vice versa. So even the volatile substances will permeate the walls and come out the same way the ink or the glue what you are used can enter into the product. And even when you are going for antioxidants or some of the reaction quenchers, uh, they may leach out and enter the product. So this is also some of the disadvantage what you can see. So the product which is used for, or the ingredients of the plastic container what you are using, you will be using like quenchers will be used, or you will be using mold release agent. These agents will be leached out from the container and it may enter into the product. So these are some of the demerits of the plastic container. But when you go for glass container, it is limited to few cases. Because of the limited stability of the plastic, you can go for glass, but disadvantage is breakage. Apart from that, ophthalmic injections or sterile powders what you are using, it will be generally packed in glass, type 1 glass bottles with appropriate stopper. Why you are going, this is the stability of the glass container will be better compared to a plastic container. And even if you want light resistant, you can use amber colored glass containers also. Which is type 1 glass container? This you have studied already. Types of glass I have told. Which is type 1 glass container? Nobody know which is type 1. At least you remember that I told there are different types of glass like type 1, type 2, type 3, type 4. Hmm? That means you are not going through the classes what I have told earlier. Huh? Next class you need to tell me the different types of glass containers. So I can ask anyone. You have to tell which is the type of glass and where it is used and what are the ingredients that is used in the container. Okay, next class I'll be asking this question. So next, so I told there are two types generally they'll be using plastic and glass. So how you'll pack it? So based on the number of doses present. For example, there are two types of doses. You know, one is single use, the other one is multiple use container. When you go for single dose container, they consist only one dose of the ophthalmic preparation, usually preparations which do not contain preservatives. So when you are going for single dose, there is no necessity to put any preservative because it is also already prepared in a sterile condition, and you are not opening at each time. So you are just opening one time and you will be using and it will be discarded. So single dose containers generally do not require any preservatives, and in order to maintain the sterility until you have to just maintain the sterility until it is administered. So there is no preservative that will be generally added. So where you will go for the single dose containers for intraocular preparation or ophthalmic injections. So this intraocular and ophthalmic injections generally will be packed under single dose container. It is not used multiple times. So when you go for multiple dose container, it requires preservative and it is packed in multiple dose containers where you will be using the same container to take out multiple doses from this. But when you go for multiple dose containers, it is very difficult to prevent the vegetative bacterial growth if there is no, if you are not adding the preservatives. So always whenever you are going for multiple dose containers, suitable preservative must be added in order to prevent the, or in order to destroy the vegetative bacteria in small numbers. Okay. So that is one. Based on the number of doses, there are two type of container. One is single dose, the other one is multiple dose container. And next one, based on the form of the container. So what are the different types of containers based on the form? So there are bottles, there are tubes like container. When you go for bottles, generally I told they'll be using LDPE, that is low density polyethylene type of plastic containers they'll be using. Bottles will be used, and the other one is tubes. So tubes are used only when you are going for ophthalmic ointments or gels. It will be packed in small metal or plastic collapsible tubes with a narrow tip. So tubes are used only for the semi-solid preparation. They are not using for any other preparation. Tubes are used for semi-solid preparation, and if required, the tubes will be coated with epoxy or vinyl plastic coated in order to prevent the oxidation and resistance. They will be coating the tube again with a layer of epoxy or vinyl plastic. Okay, so when you're going for bottle, in bottle you can see there will be a cap. So cap is nothing but the closure what you will be using that will close the bottle and prevent the breakage, sorry, prevent the leakage of or the contamination of the product. The cap or the closure what you are using on the bottle has to be prepared from polypropylene type of plastic. So again, the plastic cap will be made up of plastic, but the bottle, it can be a glass bottle or it can be a plastic bottle also. Okay, so this is about the container. So two types of containers you'll be using, plastic and glass container. And again, the types of container is, so based on number of doses, you will be using multiple dose container and single dose container. And based on the form of container, there are two things. One is bottle, the other one is tube. Okay, so bottle when you are using, there should be a closure which is made up of plastic material again. Tube will be metallic tubes are used or plastic tubes are also used. And this tube can be again coated with the line of plastic or epoxy in order to prevent any um, contamination and oxidation. Okay. So next, now you know the types of container. The next thing is what are the testing procedures that you will do for the containers. So even the containers have to be tested before you are packing or even after packing the solutions or of the use. First one is you will check for the uniformity of the volume, whether all the containers contain the same volume of the preparation. So uniformity of the container is determined. So how you will check the uniformity of volume is you will be taking 10 containers randomly and you will determine the volume of each container. Then you will determine the average volume of all the 10 containers. The average volume should not be less than the volume of any container. So this is how you will be checking the volume of container. I'll repeat. You will be randomly selecting 10 containers and you will check the volume in each container and you will note on the volume and the average of it will be taken. The average volume should not be less than the volume of any container. So that is how you will be checking the uniformity of volume. So once